Hello, this is Dr. Hena Asil, and this is the second lesson in our IGCSE Chemistry Cambridge course. This lesson will be talking about the questions and answers based on Chapter 1. So after doing Chapter 1, you should have gone to the PDF version of the questions that is uploaded on the website, and you should have tried these questions. Have you tried them? Okay, let's try the first question. Okay, so this is on questions and answers on states of matter, and the first question that you have in the chapterized questions was a question that says a gas jar of bromine vapor and a gas jar of air are set up as shown in the diagram. The glass slide in the middle between the two jars is removed. Diagram 2 shows the appearance of the gas jar after 1 hour. Which statement explains why the bromine and air mix together? Which question did you choose? Okay, let's see. Bromine is denser than air. That's not... Bromine is denser than air, but it is not the reason that the color of the bromine has spread through the two jars. Bromine is lighter than air. That's not really true. Bromine molecules move upwards and the molecules in air move downwards. Some students choose this answer, but that's not really true, because you should realize that molecules move randomly in all directions. So I cannot specify that the bromine molecules are moving upwards and the molecules of the air are moving downwards. So actually the answer is the molecules in bromine and in air are moving randomly. So that is my answer. Okay, did you get the correct answer? Okay, let's move on. An attempt was made to compress a gas and a solid using the apparatus shown. Which substance would be compressed, and what is the reason for this? Do you remember when we were talking about which one is compressible? We said to be compressible, the particles have to be originally far apart. So, which is compressible, the gas or the solid? Actually, it's the gas. And why is it compressible? It is compressible because the gas particles are far apart. So your answer is B. Remember that this is Cambridge, so you have, for the multiple choice paper, which is paper 2, you will have a separate sheet that has the choices, and you're supposed to shade in the correct answer. Okay? Okay, the next question. Particles moving very slowly, and the hint here is very slowly. So from an area of high concentration to an area of low concentration. You should realize that when particles move from high concentration to low concentration, they are doing diffusion. So you're supposed to choose the answers that are talking about diffusion. Okay, so we have two answers talking about diffusion. A substance diffusing through a liquid or a substance diffusing through the air. He says that it is diffusing very slowly. You should remember that through a liquid is much slower than through air, so your answer is C. What are the processes in the following diagram? And please take note of the direction of the arrow. The mistakes that students do is they don't look where is the arrow going and coming to. So W is going from solid to liquid. You should realize that solid to liquid is melting. So your answer is C or D. X is going from liquid to gas. Liquid to gas is what? Is it boiling or freezing? It's boiling. So your answer is C. Now, Y, where is Y? Some people mix up where is Y and where is Z. Y is the one going from liquid to solid. From liquid to solid, that is freezing. And the Z is the other one, which is condensing. So your answer is C. In which substance are the particles furthest apart at room temperature? You should realize that furthest apart means that we're looking for a gas. And the question is, which of these are gases? Ethanol, you should know that ethanol is a liquid. Methane is a gas. Salt, which is sodium chloride, that's a solid. And sugar is a solid, so you should be looking for methane, which is the gas. Okay? At room temperature, in which substance are the particles furthest apart? This is again looking for particles furthest apart, and that means he's looking for which one is a gas. You realize that H2 is a gas, hydrogen. H2O, that is water, that's a liquid. Mg, magnesium, is a solid, a metal. Magnesium oxide, you should also know it's a solid. If you don't know, then as we move along, you should know that it is actually a white solid. So your answer is hydrogen, since that is the gas. Okay, so far? Okay, oxides of nitrogen from car exhaust can spread through the atmosphere. This occurs because gas molecules move from a region of what to a region of what? By a process called what? What is he talking about here? From high concentration to low concentration, and that is called diffusion. So your answer is A. Okay? Melting points and boiling points of 4 substances are shown. Which substance is a liquid at 100? Many people choose B, but B is something that has a melting point that is below room temperature and boiling point above room temperature, which is 20. So B is a liquid at room temperature, but it's not a liquid at 100 because its boiling point is 50. So by 100 it has already boiled, so it's actually gas. So which one is a liquid? Did you choose C? Melting point below 100 and boiling point above 100. So your answer is C. Some sugar is dissolved in water. Which diagram shows how the particles are arranged in the solution? So something has dissolved, and that means you should know that the particles of sugar, can you see the key? The particles of sugar are the darker ones. If the sugar has dissolved, that means the particles of sugar should be randomly distributed between the water particles. Not on one side like A, not all below like C, not all above like D. So our answer is B. Do we understand this? Okay. Heating a liquid causes it to become a vapor. What happens to the liquids, to the molecules of the liquid during this process? So it is changing from liquid to vapor. So actually we're talking about what? We're talking about boiling or evaporation. Now, will the molecules become bigger? I will tell you that changing from solid to liquid to gas, from gas to liquid to solid, the size of the molecules never change. So you never say that the molecules become bigger, and you never say the molecules become smaller. So actually our answers are either C or D. Now, when we're moving from liquid to vapor, what happens to the molecules? Do they move further apart? From liquid to gas? Yes, they move further apart. So actually our answer is C. Do you understand how to think about these questions? Please note that the multiple choice questions are not just questions that you can just guess and answer and that's it and move on. Please think, take 1 minute or less to think about each question. Which diagram shows the process of diffusion? Again, you should realize that the process of diffusion means I'm starting with certain particles. I should end up with the same particles, but randomly distributed. So A is some sort of chemical reaction in which the particles I end up with are different from the particles that I started with. So that's not diffusion. B is the same idea. D is the same idea, and the only one that could be diffusion is C, because I'm starting with certain particles and I'm just randomly distributing them around, so that is diffusion. Some students are asked to describe differences between gases and liquids. 3 of their suggestions are: gas molecules are further apart, gas molecules are smaller, liquid molecules vibrate around fixed positions. Now, I would take each statement and think about it. Is it correct or wrong? We're talking about differences between gases and liquids. So, statement 1 says gas molecules are further apart than liquids. Is that right or wrong? That's actually right. Gas molecules are further apart than liquid. Now, gas molecules are smaller? No. We said never think about smaller or bigger. Liquid molecules vibrate around fixed positions. Liquid? No. It's solids that vibrate around fixed positions. So actually the only answer, or the only statement that is correct is A. Okay. A solid metal is heated until it turns to vapor. The graph shows the temperature of the metal during this process. Which part of the graph shows the melting. So which part is melting? Do you remember the heating curves? What is A? If we're looking at a heating curve, the parts where we're moving up, that is either solid or liquid or gas. So I would say that A is actually solid, C is liquid, and if we went up above D, we would be a gas. But the flat areas in the curve, this is where you have a change of state. So where would be melting? So melting is the part that says B. Do we agree with this? Okay, a gas is released at point Q in the apparatus shown. So this is like the experiment with the open-ended tubes. He puts a damp universal indicator paper on one end. Which gas changes the color of the damp universal indicator paper most quickly? Now that is the key. We're not saying which gas will diffuse most quickly. We're saying which gas will change the color of the damp universal indicator paper most quickly. So if we're saying which one would diffuse most quickly among these choices, we're looking for what? We're looking for the one with the smallest relative molecular mass. So actually hydrogen with the smallest relative molecular mass would diffuse faster. But you should know that hydrogen has no effect on damp universal indicator paper or on litmus paper or so on. Do you remember litmus paper, universal indicator paper? We'll revise that when we talk about acids and bases. But you should know that hydrogen does not affect. Hydrogen is not an acid, it's not a base, so it will not affect universal indicator paper. So we look at the next lowest relative molecular mass. The next lowest relative molecular mass is ammonia. Ammonia would change the color of damp universal indicator paper because ammonia is an alkaline gas or a basic gas, so our answer is A. The diagram shows how the arrangement of particles change when a substance changes state. So he has particles that are regularly arranged in regular rows, everyone touching each other, so that is closely packed, and it is changing into particles that are very far apart and randomly arranged. So which change of state is shown? You should realize that that is from solid to gas, and from solid to gas is called sublimation. So your answer is D. Propanone is a liquid at room temperature. What is the boiling point of pure propanone? Please note that there are 2 points in this question. He's saying pure and propanone, which is a liquid. Okay, he says propanone is a liquid and he wants the boiling point of the pure propanone. First of all, a pure substance would have its melting point or boiling point sharp at a specific melting point. So when I say from something to something, that's not pure. An impure substance is the one that has a melting point or a boiling point in a range. So A and C are wrong because I want it to be pure, so I want a fixed temperature. So it's either minus 56 or plus 56. Now, if it is a liquid at room temperature, then its boiling point should be above room temperature. So my only possible answer is D. Are we all okay so far? Which process causes the greatest increase in the distance between particles? So I'm looking for where is it that the particles move further apart. Condensation is what? Condensation is change of gas to liquid, so actually the particles are coming nearer to each other. Freezing, liquid to solid, and these particles are coming nearer to each other also. What about melting? Melting is from solid to liquid, solid to liquid. So the particles are moving away from each other. What is sublimation? Sublimation is from solid to gas. So which one is my answer for the greatest increase in distance between the particles? Sublimation, if I'm changing from solid to gas, that is the biggest increase in distance between the particles. Describe now, these were questions from the multiple choice paper. Now we'll go into some questions that you might see in the short answers paper, which is paper 4. Describe the arrangement and motion of molecules in a gas. So any gas molecules, you should realize when you talk about arrangement, you want to say, are they near or far, and how are they arranged? So any gas, they are far apart, randomly arranged. When we talk about motion, how are they moving? Fast, random movement. Okay, describe the arrangement and motion of particles in a copper sulfate crystal. You should realize that a crystal means we're talking about what? We're talking about a solid. So the arrangement of particles in a solid, regular rows, closely packed. The movement of particles in a solid vibrate in fixed position. Describe the arrangement and motion of particles in a liquid something. Doesn't make a difference what stearic acid is. Please, when you see a word that has a strange meaning to you, don't think about it if it has nothing to do with the question. The point is not, we're not talking about stearic acid, we're just talking about a liquid. Any liquid, doesn't make a difference. So the arrangement in a liquid is near to each other in clusters, and the motion is they move around each other. Okay, here we have a typical question. Hussein, state the name given to the change of state A, B, and C. Please look at the diagram and see the direction of the arrow in order to answer correctly. So A is something that's going from what to what? From liquid to gas. You should realize from liquid to gas is boiling. If you write evaporation, that is fine, but usually we say it's boiling. Now for B and C, please note where is the arrow for B and where the arrow for C. B is going from liquid to solid. Liquid to solid is freezing. Okay. C is going from gas to liquid, and from gas to liquid, condensation. Okay. Okay. Complete the table to show separation, arrangement, and movement of particles in each state. So for solids, he gives me an example. He said liquid, they're touching one another. So in solids, what's happening in solids? They are closely packed. Okay. Arrangement of particles, he says the liquid are randomly arranged. What about solids? In solids, they are regular rows. Now, movement of particles, he's saying the liquid move around one another, but solids, they vibrate in fixed positions. For gases, the separation of the particles, you should say something like far apart. Arrangement of particles, they're randomly arranged. Movement of particles, they move random. Okay. Now this is a question, and he's saying state the name for each of the following changes of state. H2OL, L means liquid. So in the diagram, the H2OL is a liquid in the sea. H2O, gas, G represents gas, gas is in the air. And he's using the sun. So this is from liquid to gas. Should we say, what should we say here? Should we say boiling? We can't say boiling here. We have to say evaporation, because this is just the sun. The sun is heating the surface of the water. That is evaporation. Then we have water gas going to water liquid. Water gas going to water liquid is condensation. Okay, these questions are straightforward. What is the physical state of fluorine at room temperature if its melting point is minus 220 and its boiling point is minus 188? Do you understand the temperatures when they're minuses? When they're minuses, as the minus number gets bigger, that means it's lower. So anyway, the melting point and the boiling point are both below room temperature. So at room temperature, this is obviously a gas. It has already melted and it has already boiled. But what about at minus 200? Minus 200, if you realize, that is somewhere in between these two numbers. So minus 200 is higher than the melting point but lower than the boiling point. So actually at minus 200, fluorine should be a liquid. Do we understand that? Okay. What do you understand by the term diffusion? Of course, definitions are the easiest questions that you could have. Please study the notes. The notes will give you all the definitions. The notes that are uploaded on the website in PDF will give you all the definitions that you're supposed to know. So you should learn these definitions. So diffusion is movement of particles from area of high concentration to area of low concentration down the concentration gradient. Okay, a small amount of liquid bromine is added to a container which is then sealed. Use the ideas of kinetic theory to explain why after 1 hour the bromine molecules have spread uniformly to occupy the whole container. So you're trying to explain two things. You're trying to explain that the liquid is going first to change into gas, and then the gas molecules are going to move through the container. So what should we say? First, the particles of the bromine. Remember that anything that happens, particles either gain kinetic energy or lose kinetic energy first. So if I'm moving from liquid to gas, that means it's going to take some energy from the atmosphere. So particles gain kinetic energy, move faster, move further apart, and then they move from area of high concentration to area of low concentration down the concentration gradient. This is by diffusion. Okay, that is what is happening. Okay, he has a diagram here and he's saying, is X a solid, a liquid, or a gas at room temperature, which is 20? If you look at this heating curve, you should realize that at A, it is what? At A is a solid. Now, between B and C, what is it doing? Between B and C, it's melting. And then between C and D, it's a liquid. So 20 degrees centigrade is somewhere between C and D. So at that point, it is a liquid. If I go on to D and E, what is happening in D and E? D and E is in the second change of state, so that is boiling. Okay, now he's saying, explain how the curve shows that a pure sample of this compound was used. If I look at the curve, you can see that B and C, which we should know is melting, is happening at a specific temperature, which he says is 15 degrees centigrade. The D and E, that is boiling, that also is happening at a specific temperature. That shows me that the sample is pure. So it is pure because the sample or the substance has a fixed sharp melting point and a fixed sharp boiling point. Okay, a student placed the crystal of purple potassium manganate on a filter paper which has been soaked in water. After 5 minutes, a purple color has spread out from the crystal. After 30 minutes, the purple has spread further out. And you're supposed to explain why this is happening. Of course, the kinetic particle theory is the one that says that substances or matter is made up of particles that are constantly moving. So what you need to explain is the fact that particles gain kinetic energy, move faster, move further apart, then they move from an area of high concentration to an area of low concentration down the concentration gradient, and this is the process of diffusion. Do we understand all of this? Okay, this is another graph, so this is another heating curve. What was the temperature of stearic acid after 3 minutes of heating? So 3 minutes, where is 3 minutes in the graph? You should use a ruler and draw this. 3 minutes, that's where 3 minutes is at the bottom of the graph. You use a ruler to go up to the graph and then a ruler, a line horizontal, and try to decide that point is what? That point is somewhere between 40 and 60. Decide each line, so in that case each line or each partition or each tiny little cube represents 2 degrees centigrade. So this is 42, 44, 46, 48 degrees centigrade. Do we understand how we got that? Okay. Use the information on the graph to determine the melting point of stearic acid. Again, where is the melting point? The melting point is that straight part in the graph. So you draw a line from that straight part on the graph to the temperature and decide that temperature is what. If you take a look at it, it is 72 degrees centigrade. Did you get this correctly? Okay. Please make sure that when we do a chapter, you go on and do the questions regarding that chapter, which is everything will be uploaded on the PDF. So you have notes and you have questions. When we do a certain chapter in the notes, you study the chapter in the notes, and then you go on and do the questions regarding these notes. And the following lesson is a discussion, as you can see, of all the questions and the answers that you should write. Okay, this is again the experiment with the open-ended tube. One side has ammonia, the other side has hydrochloric acid. And he's saying, state the name given to this random movement of molecules. The molecules are moving and they meet at X. This random movement of molecules is called diffusion. That's what we were talking about. State the name of the white solid formed. Okay, you should know, or if you don't, we will learn as we go along, that when ammonia reacts with hydrochloric acid, what is formed is called ammonium chloride. Suggest why the white solid is formed towards one end of the tube and not in the middle. We said theoretically it should be in the middle, but actually it's not in the middle. It's somewhere nearer to the hydrochloric acid because ammonia particles have lower molecular mass, so they moved faster or they diffused faster. Okay, that is the end of the questions on this chapter. The next chapter will be on experimental techniques, and we'll do that next lesson. Thank you for being with me. Thank you.